Great. Well, thank you all so much for joining us for an inside look at the International Space Station's Bishop Airlock from one of the men who engineered it. What do astronauts on board the International Space Station do with their trash? Do they recycle? We're going to explore the old ways of getting rid of trash on the ISS, as well as new ways that have been recently developed. The Bishop Airlock has updated the ISS in more ways than just taking out the trash. So we're joined by Solar System Ambassador Lorie Hammerstrom and Aerospace Engineer and Spacecraft Designer, Builder and Operator Brock Howe. I think, who has actually helped design the Bishop Airlock, to learn more about some of the amazing technologies recently added to the ISS. Let's see, how many? 55 of us live, and the hundreds that will watch on demand. Let's give a big virtual round of applause to Lorie and Brock for joining us this morning. And Lorie and Brock, you can take it away. Thanks so much.
Okay, thank you, Robert. Appreciate it. I'm Brock Howe. I'm an aerospace engineer, and as Robert had mentioned, I'm one of the original folks that started with the Bishop Airlock. I was ended up being fortunate enough to be the chief engineer and project manager for the project, all the way from the napkin sketch, all the way to getting the flight hardware on orbit and then operating that hardware. So where I'm at today behind me is actually a full-size mock-up of the airlock. I'm in NanoRacks spacecraft assembly and testing area. So I was fortunate enough to be able to get here, and this will kind of help us kind of see what is the airlock, how does it work, what's the size of it. The clean room is back over here over my left shoulder, and that's where just a couple of years ago we finished assembly and build out of the spacecraft prior to its launch to the International Space Station. And I was very fortunate during that process to be able to meet some really special teachers throughout the effort. One of the goals and one of the objectives of NanoRacks is to try to get the space out to the public as much as possible, kind of make space available to everyone. And Lorie is one of those ambassadors to make that happen. So as we go along, I'll present it. Lorie and I will kind of go back and forth, but we've developed a great friendship based around space and the science of space, and especially around that little airlock that we designed and built. So we're all big super fans of the airlock and really excited to be here to kind of spread the news about that and get people interested in space. So with that, I'm going to share my screen. I'll hand it over to Lorie, and she's going to talk about kind of how we met and the background between us.
So in case you haven't noticed, I keep grinning like a fool, but that's because as soon as I saw Brock and he was at NanoRacks right there where I learned about NanoRacks in person, it was so exciting. Just it brought it all right back to me. I think it was maybe February of 2019 or 2020, right before COVID, I think. If I'm not mistaken, I could be wrong. Anyway, so talking about trash, if you're in the International Space Station, what do you do with your trash? I mean, how many loads of trash do you take out each week, right? We fill up these big barrels with trash. Well, that's not as easy to do on the ISS. So let me come back because I have to share this picture with you. The picture where you see all the heads in the circle, you see Brock there, and then I'm right next to him on going up. But that was some other teachers, friends of mine, and an engineer from NASA was there as well. She's the one who delighted us by letting us come and meet Brock. But we're standing inside of the Bishop Airlock, which is now on the International Space Station. We were a little geeked out. Some teachers can get really geeky. So anyway, this is how Brock and we, the teachers and I met. And we have stayed connected. Brock's been so generous to share all the triumphs along the way of the Bishop Airlock, and it's been a really fun relationship. So, and you want to say more about the astronaut inside the airlock, because that's on station, right?
Yes, correct. Yes. So if you see the little circle behind our heads here in the picture on the right, and then that same circle is behind astronaut Soichi, who is in the airlock on the International Space Station right after we open the door and open the airlock for business. It gives you an idea also just the size of the airlock. That will become important later on and kind of how we do that, and how it can be used for trash and other aspects of the airlock.
Okay.
Okay, all right, Lorie, yeah, so that was a great time. The teachers always bring a lot of excitement for us engineers. We get kind of caught up in the grind and the manufacturing, the building, the torquing, the bolts, and the testing. And it becomes a very rigorous process, but it's fun to bring in folks like Lorie and friends to bring some energy, and then to be able to bring that energy back to the children of their classrooms and bring that energy and inspire them in STEM type activities. So it's a great way for me and our engineers and our team to bring a little energy in there, and for them to be able to bring that energy then back to the kids and inspire them for their future education.
I don't know if there are any teachers in the group, but I want you to know that getting kids excited about learning and bringing space together, you can't go wrong. They just get so jazzed about it. It's really fun.
Okay, thanks, Lorie, and I'll take it from here, and we'll talk a little bit about what we're going to talk about. So Lorie alluded to this earlier. Do the astronauts generate trash? Of course they do. So we're going to talk about that, how they bag it, how they handle it, right? We get so used to handling our trash on the ground. It's kind of an interesting topic to me, and I kind of like to talk about it because so many people can grasp what the problems might be and how is it how we handle trash on the ground versus how do we handle trash in space. So there's a lot of similarities. There's a lot more difficulties. And so this is kind of a cool topic for everybody to kind of grab onto. So we're going to talk about that. And then we're going to talk about the recycling that goes on the ISS. How do they get the trash off the ISS? Is there a space trash truck? And yes, there is a space trash truck that takes care of trash. And then what happens to it? And then what are we thinking about with the airlock? How does that help the trash situation? And then where are we going beyond this? So when we go to moon, when we go to Mars, we don't want to be trashing up those areas, right? It's just like if you go camping in a national park, you don't want to trash those areas. So we've got to be very careful and conscientious about how we handle the trash when we go out and explore the universe. So we're going to talk about all those little things here, and away we go. So astronaut trash, yes, they generate trash. Basically, 4 astronauts can generate up to about 2,500 kilograms of trash per year. That's over about 100 standard trash cans. So if you think about that in perspective of how you do that, that's about 2 trash cans a week. That's about how much trash that my family generates, and we bring it out to the curb, and the truck comes, and away it goes, and then we don't worry about it, and people take care of that. But that's not so easy on the International Space Station. So yes, they generate trash. Yes, they recycle lots of things, and they have to bag their trash. So you can see up there in the upper left, it's lots of trash bags around astronaut there inside the space station. And they have special cleanup days and chores, just like we have at home. We got to clean up the kitchen, we got to clean up the house, and generates trash, right? We bag the trash and take it to the trash can. Now, what do they do on orbit to deal with that trash? So over on the picture on the right, you can see trash collected in the bag as well. And so it's not that much different than what we do here on the ground, but it has some limitations that makes things a little bit more difficult on orbit. We're going to play a little video here. This is Mike, astronaut Mike Fossum. He kind of talks about bagging the trash. So we're going to play this. Get this going here.
Hey, Mike here. Let's talk trash. What do we do with trash on the International Space Station? Several different ways. If it's just dry trash, paper kind of things, they'll go in a plastic bag that we fill full of, and eventually, once it gets full, we compress it, kind of wrap it with tape, and we put it in a bag to collect them, ready for one of the cargo ships to head home, and we'll push them in there. For the wet trash, though, leftover food packets and things like that, we have to pack that a little more carefully. So first of all, we'll take the bits of food and put them in one of the wrappers that hold the food portions of food, come in some kind of a foil wrap, and we'll take the leftovers. There's really not many leftovers as far as food goes. We just eat it all because you want to get the air out of there, and then you want to seal these up, and that's what's really great about these. They actually seal. It's made of the same kind of material that the lining of our spacesuit is made out of. And so it's really good. It's really tough, and it's good at sealing. And you seal it by securing just kind of like a rubber band that goes around it. You wrap it a bunch of times and then push this through, and it actually holds together in a surprisingly strong fashion. Kind of get that loop under the thumb. The hard one to get started is the first one. So there you can see that the bag is secured now with a pretty good area, and that won't let the air out, because this leftover food's going to sit up here for quite a bit of time, sometimes months, before the next ship is leaving to go burn this stuff up in the atmosphere on the way down. And so you just need to have it sealed as securely as you possibly can.
Okay, so you can see there, so there's several videos out there if you want to dig into it a little bit further. But Mike, as he's showing, you've got to, one of the big differences between trash and space and on the ground is when you go throw something in your trash can in your kitchen, say, it stays there. Sorry about that. I forgot to pause it. Is that the trash can float back out again, right? We're in zero gravity, so things are going to float around. And so being able to contain that trash in the trash bag is very important. So it's not quite as easy as on the ground. And then as Mike alluded to, we're going to talk a lot about this later on. It can be months before they get this trash off the space station. So that's a big player in how the airlock can help us out. So we're going to keep on going here. So one thing you might kind of brainstorm, we'll give you about 15, 20 seconds or so, kind of think about what kind of trash is do the astronauts have to deal with. So some of the trash is the same as we have talked about already. Some of it's a little bit different. We're going to talk about that. I'm going to hand it over here to Lorie here, give you guys a few seconds here to kind of think about and brainstorm, list some of those things that might be unique to on-orbit trash. So Lorie,
why don't you
I'll
go
hand
ahead
it over to you.
Thanks. Go ahead and put it in the chat there. What things you think they might have to
Oh, yeah. Great idea.
get
Thank
rid
you.
of. Oh boy, they don't think they have trash in the ISS. I'm kidding. Wow. So this is going to be so educational. Here we go. Biomedical waste. Ooh, good one.
Yep.
Human waste. Yes. That's one of our favorite topics in education. Food packages. Yes. H2O. Interesting. Any others? Broken parts? Let's hope not. But there probably are some broken parts occasionally. All right. Let's go ahead and go from there.
Okay. All right, Lorie, I'll turn it over to you.
Okay. All right. So food wrappers and containers, which we just heard about, drink pouches, experiment packing materials like foam. So when experiments are sent up to the station, they have to be packed. And so now we have to get rid of the packaging. Containers for experiments such as syringes, applicators, etc. Not so normal things, broken equipment, old science experiments, clothes. They don't wash their clothes in space. They get one pair of socks per week and one t-shirt per month. That's how many outfits they get. Poop, there's no sewer system. And hair, periodically they cut their hair. What are they going to do about that? So those are some of the things that they do actually have to get rid of. So let's just talk a second about, somebody said nobody said urine, but I'll say it. Urine and H2O. What do you think they do with urine? You can't get rid of it. There's nothing you can do with poop, but what do you think they do with urine on the International Space Station? Because sometimes we don't just throw things away. We use them as much as possible. So what are you going to do with urine? You guys all know this, right? Yes, they recycle it. So does it say something like that somewhere here?
Yeah, they're way down.
Okay, all right. So I'll leave that alone. But But right, so they recycle it. So they, somewhere I heard them say that yesterday's coffee is tomorrow's coffee. So they just continue to use it over and over. Water is one of the most precious resources. They recycle their urine, they recycle their sweat, they recycle their bathing water. No plants to create air, so they have to recycle the air as well. And yes, when we're on, I mean, we're in a contained space with the International Space Station, but when we get on the moon or Mars, there's going to be a whole lot more. If you're at all familiar with what's happening with Artemis, they're going to have, they actually do have some plants on station, but okay, let me just get back. So there are going to be some serious, like I keep saying, what are they going to do with those parts of the spaceship that land on the moon, but that they don't, go back up to the gateway? What are they going to do with that? Because we're starting to create moon trash now. So I'm sure that they will find ways to recycle that as well. Plants. So they do have some plants on station because they've been growing things, trying to find out, can we grow plants on in 0G, right? So they do have some plants, but not enough to create enough oxygen for the astronauts to be able to breathe. And how do you recycle sweat? I don't know. That's a Brock question, I think.
Yeah, I think that's through their Spottier system. It pulls water out of the atmosphere. So as you sweat, it's a cooling process, right? As they exercise a lot on the space stations. They're going to sweat a lot as that liquid comes off their body back into the atmosphere. Then it goes through this system and then pulls that water out of the system, puts it back in the water recovery system, and then back filtered through and back to the drinking water process. So it's a really fascinating. The space station's 20 plus years old now and just operations. So it's got some old equipment there, but it's still state of the art recycling. You can imagine, as Lorie mentioned, about going forward with Artemis and going back to the moon, the even better systems that we're going to have on board these spacecraft going forward. So we need it's just a constant process of evolving and getting better and better at recycling all of our stuff, and thus reducing the trash output.
So Joyce asked if they have bathing water, can they rinse their clothes? And their bathing water, it's not like it's pretty much a washcloth and some water, and they wash, so a little sponge bath.
Yep.
So not enough to really wash your clothes.
Okay,
all right.
ready for next?
Yeah. All right, so bagging the trash, just like at home, but you can't put the trash outside. There's no garbage can outside the space station waiting for the garbage truck to come by. So what do we do with it? Is this still me or is this you?
This is to you. I mean, I could take it if you want to,
Yeah,
but
you go ahead.
Okay, so we talked about, so you got to put the trash in, and several pictures from the previous one, you see all the bags building up. There's lots of bags. Some of it's trash, some of it's experiments that are waiting to be performed. So there's just this mixture of stuff. So you got to make sure you got to kind of stow all your trash. So think about this. So if you're generating your trash, you're waiting for your trash truck. A lot of us have either outside little shed or a garage that we have our trash cans in, right? We take our trash out to the garages outside the house. They don't have that luxury on the space station. They got to keep their trash inside the house. So whether it's in the living room, in the family room, in the dining room, or wherever, this trash gets all over the place. And then they have to wait for the trash truck to show up to unload all this trash. So what is the trash truck, right? So this is basically a space trash truck. The primary mover for trash right now is the Cygnus spacecraft. It's a commercial vehicle that goes and resupplies the space station every few months. So it delivers supplies to the space station. It's up there in the upper left. And then when they're done and they've taken all the supplies out, all the fresh food, fresh experiments, fresh clothing, you name it, then they load it back up with all the trash that they've been collecting. So it becomes the main hauler for the trash truck. They also use the Russian Progress vehicles. There's an ATV and then a Japanese H2 HTV vehicle. Those don't fly very often, but the Cygnus is on a regular traveling resupply mission, but it only goes about every 3 months. So holy cow, instead of 1 day a week or 2 days a week where you get your trash picked up by the curb, it's 3 months of trash collection. That's a long time to be collecting trash, right? So what do you think that looks like as far as the living conditions the day before the trash truck shows up? You can imagine the buildup of all those things. Now, somebody may ask about the SpaceX Dragon vehicle. Yes, that's another awesome vehicle. It does free supply, but it's actually returns to Earth, and then they're able to recover equipment in the Dragon. So they don't like to use it for trash because they much rather use it for experiment samples that have been created, things that need to be brought down to the ground for further analysis and study by the scientists. So it doesn't get a lot of trash in it. It's more reserved for, say, spacesuits that need to be repaired. They bring them down through the SpaceX Dragon, or science results, those kind of things. So what do you think that begins to be like on board the space station? So this is one of the problems of where the NanoRacks Airlock can come in and try to help this process out. So you can imagine your own house. I know for my house, and just like Mike Fossum mentioned in the video, there's food wrappers, all that stuff's going on, right? And it's all in that environment where you're trying to do cutting edge science and actually live in this house with your trash building up constantly and being stowed all in the corners of your facility. So then where's the NanoRacks Airlock? So we're going to talk a little bit about the NanoRacks Airlock. I'll give you some background on it so you kind of understand what is the airlock, what's it do, and how can it help in this kind of trash situation. So what is an airlock? So some people don't kind of grasp the airlock. So the airlock is basically a doorway to space. So it's an area where you can put either people or equipment in it and be able to take it from the inside of the space station to the outside in an easy manner and without having to depressurize the entire space station each time you do it. The space station is about the size of a 4 or 5 bedroom home, so it's a very big volume. Now there's 6, 7, sometimes 10, 11 people living on board this home, so there's a lot of room. So if you had to depressurize it, you'd have to put everybody in spacesuits and all that, so that doesn't make sense. So we have airlocks. So there's actually the airlock, the NanoRacks Airlock is actually the 4th airlock to be put on board the space station. So there's 2 airlocks for astronauts. So there's one US one and one Russian one. And so those are designed to allow the astronauts to go out on their spacewalks, called extravehicular activities, or EVAs. And so they will use those 2 airlocks to make that happen. There's also a small cargo airlock on the Kibo module. That's the Japanese module on the space station. So that's designed to move cargo in and out in experiments. So small experiments that want to go on the outside of the space station to view the Earth, sample the environment around the space station, those would typically go out through the Kibo airlock, and that had been around for most of the life of the space station. Well, the NanoRacks Airlock came on board as an idea from here at NanoRacks to make that cargo, to make another cargo airlock that was much bigger than the Kibo airlock. Kibo airlock can handle something about the size of a microwave oven, whereas the NanoRacks Airlock is about 5 times the size of that and can handle stuff that about the size of a refrigerator, freezer. So that's the business case. It was developed all internally. So NanoRacks is a commercial aerospace company, which means we sell our services to companies. And so we saw an avenue and a niche market to be able to help out experimenters that wanted to send things out to the outside of the space station that were bigger than what the Kibo airlock could do. The NanoRacks Airlock was launched on SpaceX 21 back in December 2020. And I'll give you an idea. So that's a SpaceX Dragon flying away from the second stage of the Falcon 9 rocket with the airlock in the back of the and what they call the trunk. So I'm not sure if you can see. I could stop sharing this show. Lorie, can they see me as well on the?
I can see you. Robert, can you see him?
Yeah, I can see you, Brock. Brock, I would. I think folks can see what you're holding up. Yes.
Okay. All right. Sounds good. Yeah, I think it'd be better this way. So this is a model of the SpaceX Dragon vehicle, and if you look in the back of it, there's the airlock this size. So this is a scale version of the SpaceX Dragon vehicle, and this airlock, which you see here, was designed to fit into the back of the trunk of the Dragon vehicle. So there's the trunk. This is the capsule for the front, and this airlock was designed to fit inside of that trunk. So its size, dimensions, and everything is about as big as we could fly to make the airlock. So that's why we stopped at 5 times the size of the airlock. And that's a great picture about 12 minutes after launch of the separation and us going to get into orbit. That's pretty much the overview of the airlock. That's what kind of started it. Now, how is the airlock used on orbit? So we get up on orbit, a couple of pictures over here on the left. This is us coming out of the Dragon trunk. We are actually manipulated by the space station robotic arm. So you can see it in some of these pictures. So they pull us out of the trunk and then maneuver us over to what they call node 3. So node 3 on the space station had an empty port, which you can see in the bottom right-hand picture. And so that's our home now for the Nanoracks airlock for the rest of the lifetime of the space station. So that's our port where we go. Node 3 also houses the cupola. If you see pictures of astronauts in the windows of the space station, we'll see that here in a little bit. It's also home of the exercise area and the toilet area of the space station. So we're in that same module area with that equipment. So pretty neat little area. And then here's graphics showing the Nanoracks airlock installed onto node 3. We talked about the cupola, so that's kind of down below us. You see the robotic arm attached to one of the what we call the grapple fixtures, which handles the Nanoracks airlock. And then what do we use the airlock for? Nanoracks is one of the world leaders in deploying satellites and equipment off of the International Space Station. CubeSats, if you ever heard of those, small satellites. So what the airlock does is actually does the same job of what we've been doing all along the last 10, 11 years as a company, but now can do it with much larger equipment or more frequent uses, since we control the airlock and everything and control our deployment. And we're going to watch a little video of showing how the airlock can deploy satellites off of the space station. So each time we use the airlock, it's kind of a unique way of operating. We pull the entire airlock off what I call the stack of the space station and then hold it out and we deploy. And then we come back again, back to our home. So a couple of pictures here. So I'm going to try to hold up another model. It's a little bit bigger model of the airlock. So we kind of look at the airlock. Here's the big opening in the middle. The grapple fixtures that we talked about are here and over here. So that's what the space station robotic arm attaches to. And so the volume is a big open volume in the middle. And then we have a satellite that looks like maybe like this, and it would go inside the airlock and eventually be deployed off the airlock. To give you a size perspective, here is our friendly spaceman Spock. And yes, we are engineers here, so everything is to scale. So we're all real nerdy and geeky out about that. This gives you a good idea of how big the airlock is. I'm also going to get my wife Sherry to kind of demonstrate behind us the size of the airlock. So the mock-up behind us we use for astronaut training. We also use it for checkout of payloads before they fly to space. So you can see Sherry's inside the airlock mock-up to kind of give you an idea. So it's a pretty big volume. That's much bigger than what the Kibo airlock. So the whole astronauts can get inside there if they wanted to. And they do manipulation. Thank you, Sherry. Appreciate it. And so we, the airlock is pretty big. So like we said, we do astronaut training here. We do equipment checkout here before they fly. And we do also our engineers here locally can use this mock-up to design new and upgraded features. So when we did the airlock and everything, we built this mock-up specifically to help us with those kind of things, so that it's a ground analog to the flight hardware that's on orbit. Okay, so a lot of talking, kind of hang with me here. I'm going to play a little video of showing how the airlock does this deployment. So we're going to start off this video is going to show the airlock as the animation showing the airlock on the end of node 3. This is the grapple fixture down in the lower left. You can see the space station robotic arm, the SSRMS is here, and it'll go in. Now this, what would happen already is that the crew would install the satellite, they would close the hatch, pump all the air out of the airlock back into space station, and then they would pull the airlock off the stack. So they unberth it, and then they will go to our deployment location, which is 45 degrees down and aft. So when we deploy satellites, we don't want to, quote, shoot ourselves in the foot. So we do a deployment at this attitude and location. And this is all carefully coordinated with the NASA engineers in order to prevent recontact of those satellites to come back around on the next orbit and then contact the space station. So we don't want that to happen. So it's carefully coordinated. The velocities are tested and checked, and the systems are all designed to prevent that from happening. So that's how we do satellite deployment. So those could be a satellite company that taking pictures of farmers' fields or communication satellites for ocean traffic. There's lots of different people that want to put small satellites into orbit. So we have that. So, and I want to kind of stop here. I'll take a quick drink of water for 20, 30 seconds. But when you think about what the airlock could do with that, now think about how can we translate that back to helping with the trash situation. So think about that for a little bit. If you want to put some things into the chat, let me get a drink of water here real quick, let you guys kind of think on that. And then we'll talk about how did we kind of go about solving that problem as well.
And this was a lesson that we created for the kids to design a way to take out the trash.
Okay, and then, you know, at first when NASA approached us and they said, hey, can you help us with the trash problem? I was kind of like, what? You know, I don't know about this trash thing, but it's really not a whole lot different than deploying satellites. So if you think about deploying a trash bag or trash container, it's pretty much the same as deploying a satellite. It's just not quite as smart and neat as a satellite goes, but it's essential to the life and the livable conditions of the astronauts on board the space station. So away we go. So here's how we built the system. We want to deploy a large trash bag off the space station. And this is a pretty big bag. It's going to hold up to about 270 kilograms. And it's about the size of a refrigerator freezer that we talked about before. They only had the Kibo airlock, so they could only send out something about the size of a microwave. That's about essentially the size of a single kitchen trash bag, right? So it really wasn't worth it to do it through the Kibo because you just couldn't get rid of very much stuff. But with the new airlock, 5 times bigger, we can now deploy stuff that makes sense that we could fill up a large bag. So we have one large bag. You can kind of see in the lower left is one of our engineers.
Good morning, everyone, and welcome to the NRCC 22 deployment stream. We're getting things set up over here at the Nanoracks Bridge, and so we should be sharing the deployment stream of from the International Space Station shortly.
What that is.
We've just passed about T-minus 15 minutes until the deploy of Phase 2 and gas packs from the International Space Station. We'll follow up shortly with further updates.
Well, I don't know what that was about. Okay, so that was apparently some of our Nanoracks people doing some mission operations right now. So we have one big trash bag, and we have to have a guiding mechanism to get it out of the trash can. So I'll kind of go back to the model that we have here of the airlock, and then we built this one big trash bag, kind of. So it fills up almost the entire inside of the airlock. So we try to make it as big as possible, but we want to make sure that this bag comes out of the airlock. So when it comes out, we don't want to go tumble and get stuck in the airlock like that. That's a bad day for us on orbit. So we have to have a guiding mechanism. So we have built in a central guiding system that looks like this. So it's got a center pull, and it goes through the middle of the bag, and that guides the bag out of the airlock when it deploys. So down in the lower right-hand corner is one of our tests on the ground of that mechanism. So how far was this? So that's some of our ground testing that we do, our engineers do. And we always get excited about tests and all that kind of stuff. It's always fun, right? You know, it's always cool when you design something from scratch and it actually works the very first time. We're super geeked up about that. So, anyways, that will shoot the trash out. And then eventually it will go by itself, and then it will burn up in the atmosphere just like the trash truck does when it carries trash. So eventually, after about 6 months to a year, that trash bag will burn up, and you'll see a streaking arc across the sky, and that will be the space station trash bag burning up in the atmosphere. So several things that we have to do that NASA provides some really great direction for us called a ISS jettison policy. And it tells us how fast we need to go to deploy. It tells us what size bag we can have. So the bag's drag profile and its mass is considered in that. and then the direction that we deploy. And then they also provide that we have to make sure all the equipment that's stuffed in the bag is burns up in the atmosphere. So there's a lot of coordination between the NanoRacks engineers and the NASA engineers. There's people that track all this stuff. And so there's a lot of engineering going in behind the scenes of these kind of things. It looks fairly simple. We want it simple because we want it to work, but then there's a lot of background and coordination between the two groups. So then we did this, and we actually did this in a demonstration mission in July of this year. And we deployed about 100 kilograms off the space station as a demonstration. So up in the upper right-hand corner, this is the space station arm with the airlock deployed, and then the trash bag after is flown out of the airlock. We're going to watch a video of that. This is actually a view from the onboard cameras on the airlock showing the trash bag going out. And so you see it's one big trash bag. So some of the similarities between your trash in the kitchen and the NanoRacks trash bag is one, it's got cinch straps on it. So you can kind of see these straps running around the sides. That kind of takes it, combines it, and kind of crushes it into a single bag without things moving around in it. It's actually a double bag because we don't want the trash to, the bag to break, right? So if you've ever had your trash bag break in your kitchen, you know that's just a bad day. It's going to make everybody grumpy, right? So we don't want to have that same thing happen. So orbital debris is a big concern in space right now, especially low Earth orbit. So we want that bag to say is one shape, one thing to track. If it breaks into parts, then we're making a big mess in space, and we don't want to make that big mess. So we keep that thing all in one thing. It's basically just a dumb bag, though. There's no electronics on it. There's no thrusters. There's no avionics. There's nothing like that in there. It just flies by itself, and then it's...
Good morning, everyone, and thank you for joining us on the NRCC 22 deployment stream from the International.
There, okay, maybe that'll help that. Okay, so my apologies, I must be picking up the internal broadcast from our control center here, so my apologies about that. So anyways, we'll do a quick video showing that deployment, and you can kind of see how that works. Wait for the ads, of course. So here's the airlock on the end of the robotic arm. There's our trash bag deploying out. So it deploys at about, we have requirements for speed. So there's about 0.5 meters per second. So that's about a little over 1 mile per hour deployment velocity. And that's all checked on the ground per the testing that we talked about. So that's about it. That's real time. That's not slowed down or time lapse or anything. So that's about how fast that goes. And we deployed off the space station. So what does that mean to us then? So now instead of, so the big game changers here, so instead of waiting for the trash truck to show up, now the astronauts have a capability of throwing the trash bag overboard whenever they want to. So although we only deploy a couple 100 kilograms versus the trash truck taking 2,000 kilograms of trash, but now we have the luxury and the astronauts have the ability to get rid of things that on a more regular basis. So depending on how it fits in their timelines and that kind of thing, they have the ability to get rid of the trash. So lots of work going on, lots of coordination has to happen. The next deployment's planned for the end of this year or so. And then we're hoping to get more on a regular basis, and then they can hopefully get better and better at it. This is brand new stuff. Like we said, loading a trash bag in space, zero gravity, stuffing these things in a bag, and the stuff wants to come back out again. And there's lots of lessons learned there. So it's hard to load up your trash bag. But then we think this will give them a better opportunity, provide an opportunity for them to improve the living conditions on board the space station. So overall, we're helping the space station. Now, where do we go from here? So this is space station, low Earth orbit, going out to what's next after that. How do we get rid of trash on Moon and Mars? We don't have a lot of times the atmosphere to burn up the trash. How do we recycle more? How do we minimize trash? So again, Lorie and I used this presentation before, talking to kids and trying to get them interested. This is where we need the kids to get involved, and that next generation of explorers and scientists and engineers to figure out how do we do this on the future exploration. It gets harder and harder as we go further out from low Earth orbit, but these are all kinds of things that we need to talk about and figure out and inspire the next generation to be those people that figure these things out. We kind of figured out these kind of things, and it gets harder and harder. We need those really smart people to jump in and engage and make that stuff happen. So Lorie, you got anything else to kind of add to the end of that? Up here on mute.
We do have some questions, though. One question was, how many small bags fit into the big bag?
So yeah, that's a great question. So there's those little small bags that Mike Fossum had on there. I'm going to go off the cuff a little bit, engineering estimate, if you will, scientific guess, probably a couple hundred of those small bags. Now they have small bags like he had, and then they have a bigger bag that's we can fit about 6 or 7 of those. So they load those little bags in another bag, and then it kind of escalates up from there. Depends on the type of trash. The food wrappers are small, right? Some of these experiment containers are pretty big, and so they got to put the whole experiment container in there as one big item. So imagine it's kind of like your trash bag at home. We usually use a bag that's about the size of your, like a lawn leaf bag. We can probably fit about 7 to 10 of those inside this overall bigger bag.
Excellent. Will the bag deployment remove the need for the trash truck?
No, well, so that's a great question too. So one of the things, it won't eliminate it, because we can't get that much trash. We'd have to do deployments almost every couple of days to be able to remove the trash truck completely. But what it can do, the Cygnus vehicle is a very powerful machine. It's got attitude control systems and solar arrays and batteries and all this really great stuff. So our thought at NanoRacks is, let's reduce the burden of the trash truck and turn it into, and let it live another life after it leaves the space station. Maybe it stays on orbit and does more science experiments and doesn't have to be a full trash truck. So what's kind of neat about that, it's kind of repurposing or recycling that vehicle. And so it can now go do more things because it has all the systems and all the specialty devices to be able to stay in orbit after leaving the space station. And maybe it can go off and do other types of science that people never really thought of, maybe off the space station science that give experimenters opportunities to create and do neat things.
So another question that was asked earlier, they were confused about which disposable spacecraft gets incinerated with the trash, and that's the Cigna, right? This is
Yes, that's a Cygnus
down.
vehicle. The entire spacecraft burns up in the atmosphere.
And then this goes way back, but we'll do it anyway. The same t-shirt for a week after sweating on the treadmill every day.
Yeah, that's tough, right? Yeah, you can imagine the smells and everything else on board the space station. It could get rather right now. They may have a little bit more than that, but that's kind of their allocation, if you will. If you think about it, if you stay for 6 months and you have to fly up your clothing all the time, that's a lot of clothing to fly up if you change clothes every day. So yes, it's a difficult struggle. I get it with all the exercise that they have to do in order to maintain their muscle bone strength.
And Gail asked, it looks like the trunk doesn't close. How much stuff stays in the trunk, and can more than one thing go in the trunk? Oh, I'm sorry, how does stuff stay in the trunk? And
Okay.
Yeah.
Okay, so I'll use the model here. So how the airlock stays in the trunk, it's got a little nub on the side of it right here. And then there's latches inside the trunk that latch onto that, and that's what holds on there. So there's 3 of those little nubs. It's kind of hard to see there. I'll try to, but anyways, that's how the airlock. So I had a very unique special system for it. Now they can handle, the trunk can handle a variety of different shapes. It can handle one big thing like the airlock, or can handle 2 or 3 smaller items that are latched in there as well. And then everything is extracted by the space station robotics systems, and then usually they're taken out and put on the outboard outside of the space station somehow. And then that trunk is actually jettisoned on its way back in and burns up in the atmosphere.
I'm going to blend a couple of questions. Is
Yep.
the radar cross section of the trash big enough for ground radar to track it? And so can we actually see it from Earth when it burns up in the atmosphere?
Yes, so it can be tracked, and because it is a fairly big object and it has a big profile. So NASA has a group of people that track it. The Department of Defense has people to track it, and there's actually a group of people out on across the world that are amateurs that do it on their own for free. there's orbital mechanics and people involved in that. And so there's actually a friend, if you will, that I have on Twitter that tracks the trash bag and all other rocket segments and satellites in orbit for free. He does it because he loves doing it. That's really cool to me, right? So you generate these friendships, if you will, across the world of people that are really interested in these things and are very smart and really knowledgeable in these areas. And so they can track it. Now, when does it exactly enter and when does it, what's it flying over when it re-enters? That's a tough one because there's a lot of variables in there with atmospheric drag and exactly when it hits the Earth's atmosphere interface. Lots of things that I don't understand. There's a whole lot of smart people that are way smarter than me, but I don't think they can pinpoint exactly where it's going to be. But there are people that track it all the time. If I call that person up and say, hey, where is it today? He can pinpoint, here's where it is and here's your information. And I can also call NASA or Department of Defense and they will tell me where that is. So I did check with them just a few weeks ago on how the bag was doing, and they said it's looking good, and that it probably re-enter probably towards the end of the year. So really cool stuff there. That's really some really neat stuff that I enjoy interacting with people online about.
Very
Some
cool.
of the real joys of the internet are right there.
Here's another blended question. Isn't it bad to burn trash in the atmosphere? And is there any research being done regarding parasitic microbes eating the trash instead of incinerating it?
So that is a great question. So I don't know all the details about the process when it goes into the atmosphere, what actually makes it, if there's small particles and molecules that make it. I know that that it's a pretty drastic environment, several thousands of degrees Fahrenheit. So most stuff gets completely incinerated prior to going through the atmosphere. Now, one of the things I'll talk about though, is that we don't want to just throw trash away every single time. So that's the challenge for the next generation, some of the folks going forward. How can we take this, what was trash, and turn it into recyclable materials? So there's a company that we were working with that was trying to take the trash and use it as fuel for advanced engine technology. So try to use that to burn as fuel to go into outer planets, to Mars, to Moon, that kind of stuff. And there's also people that are trying to take this and then regenerate it into materials that they can 3D print on board space stations, like that kind of stuff. So that's the big challenge. Get rid of the trash, turn it into something else, repurpose it. This is kind of the edge of technology that we have right now that we're using, but going forward, we're going to have to get smarter and smarter. And it's the same goes for here on the ground. We don't want to keep up filling up our landfills and those kind of things. We want to continue to recycle and get better and better. So yes, I would love to not have to do trash. This is the best way we can kind of go about it with our current technologies, but hopefully going forward that we'll be able to hand the baton over to some of the younger folks and they can then solve some of these problems that are very difficult right now.
Is there a certain location in space where trash is deployed for any particular reason?
Not really. I mean, the ground track for the space station covers about 90% of the populated areas of the Earth. So where we exactly deploy the trash and shoot it out isn't really an exact concern, because we do know it's going to eventually burn up in the atmosphere. So we don't really deployed at any one location. What we're trying to do is try to do it where we can see the deployment, have good communications when we're doing the deployment, those kind of things. So those are bigger players than necessarily where we shoot the trash, where we deploy the trash off the station.
And do you worry about too much trash being in orbit before it burns up? Any chance a launch vehicle might have to go through that orbit and have impact?
Yes, so that's why they track it, and that's why we wanted to stay in one big bag so it's easily trackable. There's a lot of debris up there, but it's a very big space. Keep in mind that's, but they do watch that for launches and for spacecraft for like the ISS that's going in low Earth orbit. So we want to minimize that trash as much as possible. That's why the other thing you're kind of seeing that's coming out is a lot of countries are getting on board with to reduce or eliminate the anti-satellite testing, where they would shoot a rocket up from the ground, it would hit a dead satellite, and it would burst into a million pieces. All those pieces are now floating around in orbit. And so the countries are trying to band together to eliminate that kind of testing, because they know that it's generated so much stuff in low Earth orbit before. A lot of the debris control kind of started about 20 years ago, and some of the concerns maybe 30 years ago. So it's fairly new. And so people are very cognizant. The launch vehicle providers are getting better about controlling and not just leaving second, third stages up in orbit. So folks are trying to get better about that. And there's a lot of people working in other companies to send up vehicles to collect all these debris that's in low Earth orbit and get rid of it. So before it's kind of abused, but now I think as a world community, we're getting better about trying to get rid of this. So.
Are food and drink containers always plastic for the ISS? I'm trying to think of things I've seen, and I feel like they are. And if so,
yeah, I think they are.
Yeah.
Yeah, so I think they are a lot of stuff. Now, some of those are good opportunities for possibly recycling into 3D printing. They have a 3D printer on board, and that's technology that they're working through and trying to demonstrate. So I expect to have more 3D type printing. So for instance, like tools, like a wrench, right? A simple tool like that, you don't have to bring that wrench from the ground. If you need the wrench, you just print it and use it, and then you could recycle it. So that's kind of a cool way to think about things. Wrenches, those kind of things that are used repeatedly, but now you don't have to bring your whole toolbox up, right? If you say, hey, I need to use this or this or this. It's especially for specialty tools, you might be able to print them, and you might be able to print them from food packaging, recycled food packaging, that kind of stuff. So those are kind of neat areas to kind of think about. And again, areas for new folks to kind of get involved in it. So I'm kind of excited about seeing some of that coming around in the near future.
Okay, two more. We're running out of time here, but there are two more really interesting questions here. So UIUC, which I don't know what that is, but maybe you do, Brock, is excited to perform a quantum experiment on the outside of the airlock. Just don't accidentally send us down in the trash. I think that was more information and less. And then
yes, so I'm very familiar with the folks at the University of Illinois, and I'm excited about them getting an opportunity to fly on board with the airlock. That's an opportunity. That's a capability we didn't even talk about, and that we could put experiments on the outside of the airlock, which is where these little blue and gold items are. And so we will put them on the outside of the airlock, and they're going to run their experiment on board the airlock. So super excited about that. I know the folks really well at the University of Illinois. So keep up the good work, folks, and look forward to having you on board and down here, right here in this airlock, testing out your experiment here, hopefully in a few months.
That's exciting. And why do US and Russia have different airlocks for spacewalks? And which one do astronauts from other countries use?
Okay, so they have different ones because their suits are different, their interfaces are different. So they have to have kind of different ones. It goes back to a little bit about not working together, but not completely working together. And so they're not really compatible with one another. Now, it does provide some redundancy, so that's kind of nice. So if one goes down, I think there's ways that they can, in an emergency situation, use the other one. Say they went out and the US airlock went down, they can at least go over to the other one and come back in. I don't know all the details there, but anyways, it does provide some redundancy, which is nice. And they kind of use their own. Now, the second part of the question about the other astronauts, so say European astronauts or those kind of things, they all use the US airlock, and they all get trained by NASA here at the neutral buoyancy facility for their spacewalks. So most of the folks come through the US side, so they use the US airlock. Now there's a few people that have gone through the Russian airlock, and so it depends on which space agency they go to. So they come through NASA and are flying under as a US astronaut. They'll use the US airlock. If they're flying up on a Soyuz and using the Russian systems, they'll go through the Russian airlock. So it's a little bit of a mixed bag. It's convoluted sometimes. I wish we could work together a little bit better, but that's some of the politics and those kind of things. Again, remember, some of this stuff was set and forth back in the 90s. So this is 1980s, 1990s geopolitical situation. So a lot of that stuff was set way back then.
Excellent. So I know that Brock has to go. Thank you so much, Brock, for coming to help me, because excellent. It was great hanging out with you.
Yeah. Oh, yeah. It's a great time. So this is the kind of the relationships that I love about. I meet Lorie, and then we continue to be friends 2-3 years later, and we continue to try to work together to spread the news. Space is fun. It can be really cool stuff, right? This is just awesome to be able to work with this kind of stuff and the engineers, and then to be able to spread that knowledge over to Lorie so she can inspire folks and have folks like you guys here in Tewksbury to listen in make this public aware of space. You know, this is what we're trying to do, make space available to everyone and get excited about it. It's great stuff. It's great working together, big groups of people from all across the world working together to solve problems. So it's fun. Thank you.
Take care.
Yeah, thank you so much, Brock. Wonderful job. Thank you to your wife, Sherry, for doing some demonstrations for us. And I really appreciate your energy and your enthusiasm. It really comes through on the even over the Zoom. So thank you so much. Lorie, did you have any last words before we wrap up?
No, but absolutely. I saw questions coming up about sharing with teachers in Tewksbury or wherever. That's great. There are so many opportunities for teachers to go to conferences that they can get PD from, and but just so exciting. I mean, I actually got to swim in the neutral buoyancy lab with one of the experiments that they were doing. It was pretty cool. Brock is even jealous about that one, right, Brock?
Right.
I've seen the astronaut band play. I mean, I've just had so many opportunities because I'm a teacher and I teach science, and I fell into that space community of teachers, and there's just opportunities all over and not that expensive. So please do, if you're a teacher, look into it.
Yeah. Great. Well, thank you for that information. And to answer the specific question, I will share this video with the high school and middle school science teachers here in Tewksbury, their department head. So they'll get this video. So want to thank everyone who tuned in live and those that will watch the recording. Want to thank Brock and Lorie for their wonderful presentation. And folks, look for an email for me tomorrow. Those watching live, look for an email tomorrow with a recording, a feedback survey, and information about next month's NASA Solar System Ambassador Program. So thank you all so much, and I hope everyone enjoys the rest of their afternoon. Thanks again, everyone.
Bye.
Bye.
Bye-bye.